morning and welcome to today's Drought Hour. We've got some great presentations for you today. My name is Connie Strunk and I'm the Plant Pathology Field Specialist with SDSU Extension, and I'll be your host and moderator. Just like the video showed, if you have any questions or comments, please feel free to drop them in the chat or the Q&A feature at the bottom of your screen, and we'll be happy to address them throughout today's presentations. Our first presenters will be Sara Bauder and Dr. Warren Rushce. They will be talking about making lemons into lemonade, salvaging drought stress corn. So we'll be talking about some silage considerations for you to think about as we go through the latter part of the season here. With that, I just want to turn it over to Sara, who serves as our agronomy field specialist, and then Warren, who is our feedlot management, but will be taking on a different position, or maybe just took it on here shortly with SDSU. But with that, I'm going to turn it over to Warren and Sara. Thank you.
Good morning, everybody. Can you see the slides okay?
Yes.
All right, great. Always good to check before you start. So as Connie said, Warren and I today are going to be talking about salvaging drought corn. And the main focus of our talk, I'm just going to give you a brief outline, is on silage, because that's, what many of the questions are going to come in as this year. And I just want you to know that there are other options, and Warren is going to touch on them in his portion of the presentation. But at the beginning here, I'm mainly going to cover silage because that's been a bit of a hot topic. But do know that we're not telling you that's your only option. It just might be the best or a good one for many people, depending on their situation. If we can advance, there we go. So like I said, ensiling is arguably one of the best options in drought, depending on what your fields look like. And I just have a quick slide here to do an overview of things you should think about when you're ensiling drought corn. One of them is obviously we want to test for nitrates, because that's one of the big heavy hitters that we can have some issues with our livestock. So I did include there a link for the feed testing labs, and I know you can't click on live links, but if you go to our website and just search feed water testing, you can pull up that list, and that will give you some good labs that can do nitrate testing in South Dakota. And we recommend any drought stressed grass crop, especially, that you intend on feeding to get that tested this year. So the feed value of stressed corn can range anywhere from 60 to 90% of what a normal silage crop can range. So that's a pretty wide range. It just depends on whether you made an ear on the corn and how well it did through the, the stressed year of drought. So that's one thing to consider, as well as cutting height adjustments. If you remember 2012, we had a lot of corn silage that year because it was drier later in the season, and we had some issues with nitrates in our corn. And a lot of times if we cut higher, we can reduce some of those nitrates, but that's where testing comes in to find that out. You might reduce the presence of nitrates in your feed. That's the whole, arguably the best option with silage. That's where it comes from. We can keep the feed longer and we can reduce the nitrates typically after a month or two of being ensiled. So that's one of the major benefits. But again, we want to get that tested to make sure that it's safe to feed before we get it in the bunk. And then drought stressed plants, they're often wetter than we expect. Warren is going to give you a little quiz later to show you why we think that, but that is so true. Remember that a very small percentage, don't quote me, I want to say it's 15%, I should have looked that up, of the plant is in the leaf moisture. Most of that moisture is coming from the stalk and the kernels. So it's a lot of times wetter than we think. We don't want to cut it too wet. So proper harvest management is the key to good storage. So before we go any further, if possible, I'm going to ask Anne if she can prop up a poll question I have. We'll see if it works. I'll just keep talking while that pops up if we don't see it. So harvest moisture is another important thing. We really want to see our harvest moisture somewhere around 62%. And that's going to keep help keep that ensiling process going. And really the key to having good stored feed is to make sure we're putting it up at the right moisture. And a lot of times we hear people go by milk line in the kernel. Try not to confuse milk line with percent milk. Sometimes you'll hear people talk about percent milk or milk line. So in the picture here, for example, I'm showing you a quarter milk line. That would be 75% milk. So it depends on who you're talking to and how they're referring to it, but make sure you're clear on that. That 3/4 milk line though, that's really an old recommendation. And I'm bringing it up because it's still very common, because it's an easy thing to go by. It's easier than trying to do some moisture testing, but honestly, it's really not the most ideal way to do it. And I'm going to show you in a minute why. However, I want to share that with you in case that's, the option you choose to use. But plants can dry 1/2 to a point of moisture per day in the fall as things start to dry down. And that they can also be gaining 1/2 to a point of starch per day at the same time, which is helping them to dry down. As we get starch, that's drier. So things can move pretty fast once we start to see dry down. We just need to be checking it regularly. Milk line is a tool, but I would not use it as the end all be all option. And it looks like I don't think our poll showed up. So we'll just keep going unless it was, I'm just going to look here quick. Nope, I don't see the option. Okay.
Evan,
So,
were you able to load that poll?
I'll let you guys figure it out. No big deal if we can't get it. So here's a table using kernel milk as a trigger for checking whole corn plant moisture and predicting silage harvest. This is from the University of Wisconsin. They do a lot of forage work, and using kernel milk can be, like I said, a tool, but we don't want you to use it as the end all option. And I'm going to show you some others here in a minute, just to reiterate that. But here's some structures you can look at if you have a bunker silo, a bag, or a couple uprights. Your bunker silo would be somewhat similar to a pile. They just didn't have a pile in this particular table. But you can see the recommended moisture changes. It gets lower as we go to those uprights, a little higher when we're lower in those piles, simply because of the way we pack and the way that feed stores. So percent milk here, we're talking about the percent of the kernel that actually is still milk is what they're referring to in the right-hand column. Here is why kernel milk has been found to be a little less than satisfactory when using it alone to determine when we should cut. The number of samples here is 806, so there's a large sample size. This was again done in Wisconsin by Dr. Lauer, and you can see, if you look, for example, at 50% kernel milk, that ranges in whole plant moisture all the way from about 75% to 55 roughly. That's a huge range, and that's not just some random outliers. That's pretty consistent there. So the kernel milk is just an indicator. It's not necessarily something that we can rely on. What we really should be relying on is moisture testing. And the microwave method is one way to do it. Don't use the microwave in your house. You'll stink up the whole house. You want to find an old microwave on, the free rummage day or the day all the college kids move out. That's what Dr. Brooke was saying at our recent forage field day. I thought that was a great idea. And do the microwave test. And we have very specific instructions on how to do the microwave test. You want to microwave in small increments with a wet sample. So you weigh it wet, then you continue to microwave until it's dry, basically, until you get the same moisture repeatably, and you just microwave in increments. Otherwise you will burn your sample, and that smells even worse, and then you have to start over. So that's one way to do it. It's cheap, it's easy, and when you're done, you have a wet weight and a dry weight, and you can easily figure out percent dry matter by taking the dry weight divided by the wet weight. Times 100 gives you a percentage. Or you can use a Koster tester. Some people, large dairies might have these. If you're a smaller operation, you maybe don't have one, but they are a good investment. They take about a half hour or less, maybe, depending on the sample, and they will dry it down quickly and accurately, and you don't have to worry about burning it. And you can plug it in the shop, don't have to worry about doing it in the house. So couple options, but we really want you to measure the moisture in your field rather than just going by milk line. The milk line can help you determine maybe when to start checking that moisture. And here again, I just am showing a picture of a Koster tester, and you can take that dry weight divided by the wet weight times 100, and that'll give you dry matter. If you want to do it in moisture, you just take 100 minus that dry matter, and you'll have your percent moisture. So drought stress corn, And I'll remind you, if you have questions, catch me at the end or in the chat, because we've got a lot of info in a short period of time here. So I'm trying to leave room for Warren. You can cut me off, Warren, when you need to. When we're talking about drought stress corn, so these are some average numbers just to kind of think about. Corn can use 24 to 27 inches of water per acre on average. That's a lot. Some of us don't even get that much, especially not this year. So we're definitely going to see some drought stress in some areas. If we see repeated stress from silking to tassel, we can see some pretty significant grain yield losses. So if you're out in your field and you're not seeing the ears or seeing developed ears that, maybe they didn't fully pollinate because of the heat and the pollination got off timing, then there's some things to think about. These are very general rules. Again, you want to moisture test, but to give you an idea, if there's little or no grain, a ton of 70% moisture yields about yield per foot of plant height, So per every foot of plant height, we're going to assume about a ton of 70% moisture yield. And then if you have green barren stalks, you might have 75 to 90% moisture. Those stalks can still have quite a bit of moisture in them. The leaves really don't make up that much of the overall plant moisture. So just keep those things in mind. If that's hard to look at on paper like that, then simply you can go out and start moisture testing to give yourself an idea. You can do that for free at home. The stover, again, is usually wetter than expected, but when we start with that ear development, that's when we really start to see moisture in the kernels. But as soon as that starch starts in, it'll help to dry down. But that starch development is lacking when we're behind and we're drought stressed. So things are probably wetter than we expect. And then make sure you quality sample. Again, nitrates are very important. Dry matter, NDF for digestibility, sugar, starch nitrates. If you want ash content, a lot of labs will do that as well. So it's always important to get those samples so we know what we're feeding. Two other factors to think about: length of cut, without going into great detail. Shorter is typically better for packing and gives you an increased surface area. However, longer can help. Excuse me. Okay, sorry. Longer can help with our physically effective NDF, and it might increase some bunk sorting. So there's benefits of both and everywhere in between. Sorry, I swallowed wrong. Bad timing. So benefits of both and everywhere in between. However, if you're really worried about packing, somewhere on the shorter end might be better, but there are benefits to a longer chop length in some situations. Just something to be aware of and to think about when you start cutting. And the other thing is kernel processing. So if you have the opportunity to kernel process, chop length maybe isn't as important for digestibility, but if you can't kernel process, sometimes chop length can help us to break up kernels better if we shorten the chop length. And Warren probably can talk more on the animal side of this, but just from the harvesting standpoint, we get increased digestion as we increase our kernel damage, and we want to be checking this several loads per hour, especially on large operations where we're putting up huge amounts of silage quickly. So I suggest you use the processing cup. I'm not trying to endorse Pioneer or Corteva, but they have some great, excuse me, they have some great tools in a silage manual that I'll reference at the end of this. But one of them is this corn processing cup. So what you do is you fill this cup several times an hour, and you dump it out and sort. If you see more than 2 to 3 whole or half kernels, you need to start making adjustments to the chopper ASAP. Okay, so that's the whole idea of kernel processing, is to get them processed. And you can see, I just got this cup, so it hasn't been used in the silage yet, and my helper grabbed it this morning. I thought that was a good picture of, alternative uses of the silage cup. But it's handy. It even has the instructions on the back. The other option is to do some fecal sampling from your cows to see how you did. However, it's too late to change your pile then, right? So we want to do it as we're cutting. Storage-wise, so of course, when we're harvesting and filling, we're in an aerobic environment. And then once we start putting it in the pile, the bunker, the silo, we want to cover it and get it in an anaerobic environment. But we start feeding and it gets back to getting some air, depending on how it's stored. So to get it to ferment, of course, we need an anaerobic environment, and that means it needs to be covered tightly. When we're trying to ensile, we're trying to stabilize the feed through lactic acid bacteria action. So we want to get that lactic acid really going, get that bacteria and those bugs happy, and we need no air for that process to happen. Things to watch for though are yeast, molds, soil contaminants, especially on a dry year, we want to watch for yeast issues. So this is why putting it up at the right moisture and putting it up in an anaerobic environment where it can ferment properly is so important, and getting it packed tightly. Packing and sealing are really important to that anaerobic environment. So it's more than just covering. We want to eliminate porosity and spend some time packing. A lot of times what happens is choppers can go faster than packers, and they just keep coming. We want to get it done. We keep dumping it on the pile, and we don't get it packed well enough. We don't want to be packing layers that are more than 6 inches depth in piles or bunkers. And there's also, I didn't want to get into it, but there's some methods that are suggested. You want your sides, I believe it's 30% slope on a pile, and then your bunkers, you're best to pack in a wedge instead of packing in a flat pile. But there's a lot of information on that in the Silage Manual as well. Packing densities should exceed 15 pounds of dry matter per cubic foot, but who knows what that is, right? Unless you're out there testing it and coring it as you go. What we can do is take our tons of silage per hour times an 800-pound factor. That gets us to that 15 pounds dry matter. It's a factor figured in, and that gives us the pounds needed for packing. So for example, if you're getting 100 tons as fed per hour dumped to the pile, you take that times 800, you need 80,000 pounds of packing weight. That's not counting your push tractor. So that's a couple tractors most likely. And a lot of us probably aren't packing well enough. We're getting too heavy of depth, and we're not having enough tractors pack at a time and taking the time to pack it well. It's really hard to overpack. The only exception that we see is a lot of times people will take the top layer and just drive over the top layer thinking they're packing the pile, but it really doesn't do much good. At that point, that's been tested and proven. You really need to pack as you go. Packing the top layer repetitively more than you typically would with a layer isn't going to pack your whole pile or really help you a whole lot. So we want to make sure you're covering that with an oxygen barrier and plastic, or at least plastic at a minimum as soon as possible. That's what really creates that anaerobic environment. If we don't cover our pile, we're going to have a lot of waste. So just a couple slides I just want to briefly get through. So this is a slide showing us basically dry matter losses. You can see as you look across the screen from left to right, the percent shrink as it increases. And so if we look at $6 corn at 10% shrink, we've got 756 we're losing, and at 22.5% shrink, we're at 1702. So losing and those dry matter losses are really important. We're losing nutrients when we lose dry matter, and then just throwing it out there as feed doesn't do us much good either, and we can have some risk of contamination in that moldy feed. So just trying to reiterate the importance of putting up your silage well. We just packed these tubes for our forage field days last week, and I just wanted to show you a neat example. Might be a little hard to read, but it's 1/4 inch, 1/2 inch, and 3/4 inch chop lengths. So the lengths get longer from left to right, and then the packing densities increase in each of the 3 sets from left to right. And from this view, you can definitely see how the packing density changes how that silage looks and packs. And we packed these by hand with a post tamper, and it was very obvious. The left-hand side of each group, there's airspace, harder to see in this picture, but there was airspace and it was really easy to pack. And by the time we got to the tubes on the right-hand side of each set, we were using some serious elbow grease and actually couldn't reach the packing density we wanted to in a couple of them. So just kind of a neat example of what packing density can look like and how that air porosity really changes. So of course we want to avoid spoilage, use the right moisture, use good compaction, good feed out methods, keep that face as flat as possible and show us the least amount of face as we can on a pile or bunker. Using inoculants is very important. I didn't get into that today, but inoculants are very helpful in piles and keeping them on as we're packing. And then of course, use a quality covering. So want you to be safe with silage. I always throw this in when I talk about silage. The Keith Bolson Safety Foundation. Keith passed away this last year, but he did a great job of getting silage safety out there. A lot of people don't think about the fact that when you're standing near a pile collapses are quite common. There's several deaths every year in the United States alone from silage collapsing on people. So if you're taking samples, be very careful. There's several protocols to take, and you can go to this website. They have lots of great safety books out there, and they'll give you all kinds of good information on silage safety. Of course, gases are also an issue with silage. And then I just want to throw this in, last but not least, keep your soils covered. As an agronomist, I got to throw this in. Silage might be the option for you this year or maybe every year, but it's a really easy opportunity to fit some cover crops in. So I've got the 5 principles of soil health there. Keeping our soils covered is one of the big ones, and having living roots. So following silage, there's a lot of opportunities to put in cover crops, and I've included some links on the slide here. Once Warren gets talking, I can throw those in the chat for anyone that's interested. Here's the resources I used. Big one I want to push is the Silage Manual. Again, I'm not trying to endorse Pioneer or Corteva, but this is a great manual. A lot of extension experts across the country suggest this manual. So I can't entirely tell you where to get it, but I know if you go to their website, there's information on it. I've been able to get one free at various field days over the years, but hopefully a local rep could hook you up with a book if you're interested. That's my contact, and I am going to switch over to Warren, and Warren, I can advance slides if you prefer, or let you share the screen.
I'm going to try sharing the screen.
Okay, I'll stop my share.
Oops, hold on. Bear with me. Okay, I think we're good. All right, can everyone see the slide that asks what the moisture content is?
Yes.
Okay. It always makes me nervous, this swapping screens back and forth, and I've put up a poll question. These pictures were sent to me by a producer in Western South Dakota. They harvested this last week. Obviously, you can't quite tell the ears, but it's drought stressed corn. There's not much there. So they harvested as silage. And this person also told me what the moisture content is. So we're all going to play amateur is it ready to chop contest today. I'd like you to give me your estimation of what the moisture content of this was last week. And I can't see when people are done voting. So I'll give you guys just another minute or two, and then we'll switch. Or then I will give the answer. Wait a minute, here we go. Nope, never mind. All right, I'm going to give the answer. I'm assuming everyone's had a chance to vote. This corn was between 70 and 75% moisture. Too wet. Quite frankly, because what's going to happen, and Sara talked about, and I can see it's about like I thought. Most people, as Sara talked about, on drought stress corn, it is wetter than you think it is. Ideally, this person, I checked on the list of participants, this person isn't on, so I'm not picking on them. It's an easy enough mistake to have to do, but this person should have waited probably another week, 10 days, because Sara talked about, what happens when, given some recommended ranges. If I'm going to make a mistake on chopping silage, I would rather be too dry than too wet. And the reason is, and we'll talk about nitrates in a little bit, but even on normal silage, if we try to ensile crops that are too wet, we're going to get clostridial fermentation, which results in butyrate formation, and all the scientific part of it. In layman's terms, we get a bunch of smelly, slimy stuff. The cattle don't eat well, they don't perform well, and increases our risk of clostridial bloat in the feedlot. So from that standpoint, being too early is really a problem. We want to be, we need to make certain we know what this stuff is, because we can't really go by green color. All right. Whoop, I'm sorry, wrong way. Okay. Sara talked about nitrates, and she mentioned, that is one of our primary concerns with drought stress forages. In a nutshell, what's happening is the plants are taking up nitrogen, but they can't turn it into plant protein or use that to drive starch accumulation. When the animal consumes high nitrate forages, the nitrates are converted to nitrite. Nitrite interferes with the oxygen carrying capacity of the blood, eventually causes these the livestock to die because they simply can't get enough oxygen. Under normal circumstances, if we have normal type of fermentation, we can expect reduced nitrate levels by 25 to more typically 50% if everything goes well. So that's one of the key reasons why when we talked about ensiling being the preferred method to dealing with drought stress corn or sorghum silage or any of these crops that can accumulate nitrates, that's the reason why. It gives us a measure of safety that we can't get if we use other harvest methods. Here is our chart in terms of what the different toxicity and limitations are. I want to draw your attention to 2 points on this table: the 1,000 parts per million level and the 4,000 parts per million. If we're under 1,000, we really have no limitations at all. It's safe to feed any class of livestock. When we're over 4,000, we have a real problem. It's too challenging to try to blend this off, because if there's any kind of hot spots or places we didn't mix well, we could have some death losses or abortion risks. In between, now we have to start thinking about either diverting this feed stuff to non-pregnant livestock or diluting it out with some other feedstuffs in order to reduce the risk and get it to a point where it's safe to feed. I'm going to talk about a couple other different options that people could do to salvage these feedstuffs, because we realize that harvesting a silage isn't without its challenges in terms of equipment cost, time, and right now the big issue is transportation. How far do you want to haul a high moisture crop with a lot of water in it? So one of the questions we get asked is, can you graze the corn? And for a lot of this, I'm relying on some information from Dr. Mary Jarnewski from the University of Nebraska-Lincoln. I was on a program with her last week that Sara conducted, where I posed this question to her because she's done a lot of work on grazing cover crops. And I knew that their experiences were that feedstuffs that the laboratory tests from nitrates said would be a problem, that they were able to successfully utilize those crops as grazing. So the answer really is, if you can you graze it? Yes, as long as we're careful. Part of the reason we can utilize higher nitrate feedstuffs through grazing is they're taking smaller meals over a larger portion of the day compared to if they were being fed in a feed bunk or self-fed stored hay. So what's happening is the animal is able to tolerate or metabolize the amount of nitrate they're consuming in such a way that it's not tying up, converting the hemoglobin to methemoglobin where they suffocate. The other portion of that is we're taking advantage of the animal's selectivity when they're grazing. Nitrates are as Sara talked about, the greatest concentration of nitrates on the bottom half of the plant, not on the top. So if for the most part, if those cattle are mostly grazing the top portion of the corn plant, their dosage is less and consequently the risk is lower. From a safety standpoint, this was Dr. Janewski's advice that really want to consider taking some samples, ideally from both the top and the bottom portion, because that's going to give us a fuller picture of what our risk is. That if the top portion of the plant is really low, but there's higher concentrations in the lower portion, that's going to tell us how much of that standing corn we can utilize. The picture I have here is from the Southeast Research Farm with some grazing work they were doing on annual forages. I think this is oats in this case, where they were using an electric fence to set up strips to really optimize efficiency of grazing. That is not what we want to do in this scenario for grazing standing corn. We want to leave the bottom portion of the plant because that is where the nitrates are. So in this case, we don't want to restrict access. We really want them to be, I guess, really relatively inefficient in grazing. Take the top half, flash off that part of it, and then we're going to move on to another field as a way to reduce risk. This question comes up every year. In fact, it came up this last week when I was in Beersford at Sara's program. Can we salvage corn by baling? We can, but there's some challenges with this. The biggest one is we got to be able to get this stuff dried down enough so we can keep it in a bale. if our objective is to turn a standing corn crop into manure without taking the time and trouble of actually feeding it to livestock, wrapping this up in a bale too wet will do that job nicely. It just doesn't store well. Any crop doesn't store well. The challenge with corn is that stem holds it off, just like everyone got fooled on that picture of the standing corn. We have the same problem. We're trying to estimate the moisture content when we bale it. In 2012, during similar drought conditions, we did bale up some corn stalks down at Beersford, and we're able to do that successfully. We got it down to 85% dry matter, 15% moisture, but it took 30 days to do that. So if you're willing to let that kind of time go by, and you're willing to take the risk of whatever kind of weathering losses we might have from exposure from that crop laying that long, it can be done. It's not going to remove nitrates. So if that's a concern, we're still going to have those. And really, in my estimation, the only time this really fits is if you tell me that I've got corn that's 30, 40, or in the case of the call last week, 130 miles from home. This may be our best option to if we need the feed. This may be the best option, but it certainly has some challenges. Sara did a really nice job of laying out all the steps to storing silage and minimizing shrink. So I'm not going to go through all of those, other than to say, a lot of the stuff she talked about, and the information was spot on about, kernel processing and some of those things. Honestly, though, if we can't manage this, like I've showed on this slide, the rest of that doesn't matter. We've done some work with kernel processing on feedlot cattle and can't show a difference. I can guarantee you, though, in these kind of situations where we can't manage shrink losses, that we could go from a 10% shrink dry matter loss to 20, 25, or 30% losses. And at the feed, with our challenges this year with feed availability and feed costs, those are simply factors we can't afford to ignore. And I haven't even talked about the concerns you're going to have with trying to feed spoiled silage. Sara mentioned Dr. Bolson. They did some of the research work where they fed spoiled silage to cattle. Digestibility falls off, intake falls off, performance falls off. There really is nothing that you can say about you trying to use spoiled silage. I'm going to spend a few minutes talking about how might we price this, because that's the other question that people are throwing out right now is, what is this worth? You've got on one hand a crop farmer that's got silage corn crop that's not going to be acceptable in terms of harvesting for grain, is looking at how can I price this to someone else. There are a number of rules of thumb and calculators that are out there. I've used this kind of a real rough rule of thumb that if I take the price of corn times 10 or 12, that comes awfully close. And under normal circumstances, those work fine. The problem is, what do you do when normal isn't applying this year? It's awfully hard to value a drought stress corn silage based on the price of corn when there's no corn in it. In the same token, we could do something relative to hay as a dry matter basis, but as a livestock producer, if I'm looking at a market where hay is too expensive because the supplies are short, I'm not all that excited about pricing and alternative feed stuff based on as a percentage of an already inflated hay market. So what I came up with, and I've been thinking about this a lot over the last few days, is thinking about this from a standpoint of how do we manage uncertainty. If we know most of these variables, such as I know what the dry matter is, I know what the nutrient composition of the feed stuff is, I've got a pretty good idea of what my harvest costs are per ton, then valuing this is not that hard. Then we could use that actual data, reference it to some other known feed stuff, something like probably corn on a TDN or net energy basis to derive a value, because we'd know the dry matter and I know the nutrient composition. So then we know how much TDN was per ton. We know what corn's worth. The TDN of corn is well known, somewhere around 72%. So I can derive a value per pound of TDN, make some adjustments for storage losses and harvest costs, depending on how the arrangement's going, and we can come up with a value. Now, one of the challenges here is there needs to be a really high degree of trust between the person who owns the crop and the person that's buying it, because once it's chopped and in the pile, it's a little hard to get back if you can't agree on the value. But this would be the most ideal, in my estimation, the most ideal way to price corn silage in a year like this in particular. What I often, where I end up though getting questions a lot of times is, what about the crop that's just standing there? If someone says, I'll sell you this field, so much per acre, so much per ton, what will you give me for it? Or I want this much. The challenge here is the amount of uncertainty we have. If you look at a field like that, it's hard to estimate what the yield's going to be. We've already shown that dry matter content is really hard to estimate just by visual appraisal. And as Sara mentioned, that drought stress corn runs from 60 to 90% of the value of full corn silage. Well, there's quite a bit of difference between 60 and 90%, depending on which end of that spectrum we're on. So, as we increase the amount of uncertainty, we effectively lower the expected value, and most importantly, we increase the risk, and therefore we lower the value of what I could reasonably afford to pay for that corn silage if I'm a livestock producer. Now, someone might be hearing this and say, "Oh gosh, Rushce, you're being awfully hard on the crop side today and kind of kicking them when they're down, dealing with drought and everything else." But let's flip around the analogy and see if this maybe makes some sense. Suppose that I, as a feedlot operator, had some manure that I offered to the crop farmer that, I'll load it with my loader. If you cover the spreading costs, what will you pay me for it? Well, that person doesn't know what the composition of the manure is, doesn't know how much there is. So it's really hard to estimate how many acres he's going to need to cover, and has less than ideal knowledge of what his transportation and spreading costs might be. So, in that scenario, it's perfectly reasonable that crop farmer is going to want to reduce the bid, so to speak, on the crop manure to reduce his risk. Sara, some of the other part of some of these conversations sometimes goes the other direction, and this was a phone call from last week also, where the crop grower, he has a neighbor that would take the corn, just doesn't want to pay for it. He said, "I'll take it. I'll cover the harvest cost, and I'll take it off your hands." Well, that's not realistic either. We know there's value, in terms of organic matter to the soil, crop nutrients, and so forth. Sometimes estimating that is challenging. At least it is for me. I did a quick poll this morning amongst our agronomy team, and I didn't get the easy answer I was hoping for, which is probably to be expected. But somewhere I would think at least $10 a ton, just from an agronomy, crop nutrient, crop organic matter standpoint. Maybe some value also, and Sara mentioned about keeping things covered, and this was a point that Anthony Bly, one of our agronomy field specialists based in Sioux Falls, brought up, is there may be some real value to leaving some strips to catch snow and to prevent some wind erosion, especially if we're thinking about growing conditions this spring, fall, where getting cover crops established might be challenging. Here's my contact information. Again, you can find us, myself, as well as everyone else online at extension.sdstate.edu. With that, I will stop sharing the screen, and I will open things up for questions or turn things over to the next speaker.
Evan, would you be able to load the poll real quick as I prepare to share Adam's screens? If it looks like enough people have filled out that poll, you can go ahead and close it whenever you feel ready there, Evan. I can't see when. Thank you. I'm going to share Adam's screen here as we'll transition over for the next presentation for Drought Hour. It's always a bit of a lag here, sorry. Oops. I'm gonna introduce Dr. Adam Varenhorst, who will talk about grasshoppers, spider mites, and blister beetles. So with that, I'm going to turn the mic over to Adam for his presentation. And then, like I said, at the end, we will grab any questions, comments, stuff from those that are viewing the presentations. We thank Warren and Sara for their presentation. With that, Adam, you're free to go ahead.
All right, can everyone hear me now?
Yes.
All right. Having a little snafu there with technology. One of the challenges, I suppose, of being out in the field. So I'm Adam Varenhorst. I'll be talking about grasshoppers, spider mites, and a little bit on blister beetles today. So Connie, next slide. So one of the big things we know is going on in South Dakota this year is it's dry. And with drought comes some different problems, especially with insects, primarily grasshoppers and spider mites. Now, right now, these are the most up-to-date conditions. So this will be updated this upcoming Thursday, and we'll see how things have changed. I know some areas of the state had quite a bit of rain over the weekend, but some areas did not. So the areas we're really focused on right now are those orange and red areas that are shown on the map here, where we have severe to extreme drought. And that's where a lot of our pest problems are starting to show up. You can go to the next slide. And one of our pests that I'm getting a lot of calls about in this last week or so are 2 spotted spider mites, primarily in soybean. Now, these are very small. As the picture shows here, they get their name because they have 2 what looks like black spots on each side of their bodies. That's actually just their internal organs. And because they're so small, it can be very difficult to see them on the leaf. Sometimes it'll almost be impossible. One of the easy things to do is take a white piece of paper along with you and knock leaves onto it, and then see if you notice any small spots. They almost will look like a period at the end of a sentence in a newspaper when they're on the white paper. Now, another thing that can be done is to use a hand lens, and that will help you see those as well. You can go to the next slide. And 2 spotted spider mites really thrive during hot, dry conditions, which we know we're having throughout most of the state. And one of the reasons why they do so well during the dry conditions, and especially with heat, is that on a normal year, these are typically maintained by natural enemies. And one of those natural enemies is a group of fungi that require high humidity conditions, but when conditions are right, they can go through a population of spider mites and essentially remove them from a field in a matter of a few days. Now, because of how spider mites show up in the field, they typically show up when grasses dry out and when conditions warrant them to move. They'll show up, and a lot of times they'll show up later in the season. However, this year we started seeing them as early as the first week of July, but those populations were somewhat low and didn't require management. Now, as the conditions out in the field are changing, and we had that week of high heat, spider mite populations have really taken off. You can go to the next slide. So how do we scout for 2 spotted spider mites? Well, it's a little bit difficult. It's one of those pests that we can't really monitor and manage from the road. We need to get out in the field. So what we look for are discolored patches in the field. Now, during drought conditions, those could just be dry spots, but you won't know until you get out there and start looking for some of the symptoms of spider mite infestations. So one of the things you look for is what we call stippling, or essentially small white holes that will show up on the leaf, like pictured here. Now, when you get a lot of spider mites, you'll start to see the leaves almost becoming a white color, as shown in this picture. That's a lot of stippling. So a few will leave a few little white spots on the leaf. And as you get larger and larger populations that are feeding, you will see greater discoloration, and eventually the leaves will be completely discolored. You can go to the next slide. Another thing we look for is webbing. Now, spider mites aren't going to make spider webs per se, but they will make webbing that you can see on the bottom of the leaf. And it's almost going to be like a webbing covering over the entire leaf surface. And so it's very fine, but you'll be able to see it, especially if you hold the leaf to the sunlight going over those trichomes. As shown here in the picture, the spider mites actually use that webbing for mobility. So they use it to crawl around to different parts of the plant and over the leaf surfaces. You can go to the next slide. So this is a chart, and this is from an extension article that we have up on our website right now. This shows our rating and decisions based on the populations of the mites present in the field at the moment. So if mites are in low populations in dry areas and there's not a lot of stippling, or they're on the field edges where they typically will show up first, we don't need to treat. If the mites are easily found in those dry areas within the field and on the field edges, but the leaves are still green, but there's a little stippling, we don't treat, but we do know we need to keep scouting. So that could be an issue in another week. If you are noticing a lot of stippling in the dry areas, most of the plants are infested with spider mites, and the speckling is on the stippling or speckling on the bottom leaves, and the bottom leaves have become that white color like I showed in the picture. Treatment's warranted. And then once we get past this stage, we're almost getting into that revenge territory. So the next level is all examined plants are heavily infested, severe damage evident. Treatment's warranted, but we might not recover yield loss. So there still could be some yield loss occurring. And then the last observation is majority of the field is discolored, leaves are bronzing and falling from the plants. At this point, we probably aren't going to recover. So we can treat, but we aren't going to recover or prevent any additional yield loss. So things have gone too far. So we really want to be out there and watch just when we start to see some discoloration on the lower leaves. Every plant that you examine is infested, you'll see the webbing. That's when it's a good time to treat. And go to the next slide. So what do we use? One of the things we have to be really careful with is that although labeled for spider mites, there are quite a few different pyrethroid active ingredients that have been known to actually flare spider mite populations. And the reason for this is we're actually removing the natural enemies that are out in the field, and we're not killing the spider mites. And so some products that do work for the most part, one is actually a pyrethroid, bifenthrin. That's been known to work pretty well. Organophosphates work pretty well. And then there are some different miticides out there on the market, and those should work as well. So those are our best management options for two-spotted spider mites. Another thing you can do is just wait, look at the forecast. If there's rain in the forecast and you end up getting rain, a lot of times that can be enough. You get the humidity up in the canopies, and then as a result, those fungi that are out in the environment will take over and they'll wipe out those spider mite populations. I've seen it before back in 2012 where we had severe spider mite populations on a Friday, come back on a Monday, and they're completely gone because it rained Friday night. And so all we could find are little carcasses on the plants, and there weren't any live spider mites anymore. So those fungi are no joke, but we have to have those right conditions. This morning in a lot of the eastern part of the state, it was pretty foggy. That even can help us. Just any way that we get the environmental humidity to increase out there, that's going to help. So you can go to the next slide. So what's our next pest? This is actually a picture from last year. This might look like a hailstorm went through our sunflower, but it wasn't. So if we go to the next slide, we'll see who the culprits were, and they were two-striped grasshoppers. Grasshopper populations in several parts of the state were pretty bad last year. Now, given the conditions we've had over last fall, this spring, and during the summer, we've heard a lot of reports of bad grasshopper populations. We've heard reports from some neighboring states. Grasshoppers will move around. So once they run out of food in one area, they'll start moving to another area. And so we've been seeing some increased populations in South Dakota too. You can go to the next slide. So the main three species that are really pests that we watch for year to year are the differential grasshopper on the left. These are fairly large. They're a green to tan color grasshopper, and their main characteristic is on their hind legs, they have black chevron markings. Now the middle grasshopper are the two-striped grasshopper. Those are the ones we had a lot of problems with last year in the central part of South Dakota. They get their names because if you look at this picture, they have those almost yellow-white lines that start at their head and run down their body until they converge toward their abdomen. And then we have red-legged grasshoppers. And those are much smaller than the other two species, and they get their names because the hind legs are red. So of the species that we're seeing this year, primarily we're seeing two-striped grasshoppers. We always see differential grasshoppers out in the environment, but a lot of our areas, when we get into north central, northwestern South Dakota, it's the red-legged grasshopper causing a lot of issues. And I've seen some pictures on social media of the grasshoppers covering fence posts, and you know that was an old saying. I know it came from the Dust Bowl. You know it's bad when you start seeing the grasshoppers showing up on the fence posts. And, you know, when we see that during a year like this, we know things are bad. So what do we do? How do we take care of this? Well, we know populations tend to be worse during dry years. The reason for that is they have, especially when we have a later frost, they have a good reproductive season. When it's dry in the spring, we don't see a lot of egg mortality. So what was laid, most of it hatches. So we need to monitor grasshoppers throughout the season, not just this time of year. Population monitoring should have started as soon as the crops were planted, looking at row ditches and seeing how bad of populations we were seeing. I know in some fields I was in last week, you could see that the edges of the field were much later planted than the rest of the field. The reason was that the grasshoppers moved out of the grass in the spring, wiped out the first 100, 200 feet of the crop, and then that was replanted after the grasshoppers were sprayed. So we know that these dry conditions are increasing the grasshoppers for this year, but another thing we need to think about is what will things be like next year? Now, the defoliation grasshoppers cause this time of year can be problematic if it becomes very severe, like the picture I showed. However, especially in crops like beans, not as much of an issue. They're pretty tolerant of defoliation. It's when we start seeing them feeding on the harvestable parts of the plants. So for sunflowers, the heads, beans, the pods, and corns, the ears. If you get a large population of grasshoppers, they will clip silks, and that can be pretty problematic too. So if we see them feeding on the harvestable parts of the plants, we pretty much immediately go to a treat decision, especially if you're seeing it throughout the field. So we scout grasshoppers primarily this time of year using visual counts. In soybean, we can use a sweep net, but it's just easier to count and see how many we're seeing in a square foot or square yard, sorry. So for the threshold for nymphs, which we aren't seeing as many right now because we're mainly to the adult stage, everything's a little bit further along this year. The threshold would be 30. Oh, sorry, Connie, next slide. The next threshold would be 30 to 45 nymphs per square yard, and it would be 8 to 14 adults per square yard. Now, I get a lot of questions. How do we scout? They're moving around. Am I double counting? Well, it's kind of use your best judgment. Stand still for a little bit and just monitor how many you're seeing on the plants, how many are jumping, and you count those. And then you move on and do that in another part of the field. If the grasshoppers are above the threshold, the best treatment are foliar insecticides. For rangeland, there are also some baits. However, we were contacted by the one company this year. They had a loss of their colonies. And so we know that especially one brand of the baits is not going to be very available this year. So foliar insecticides, and with grasshoppers, we always recommend reading the label. Most of the labels will tell you to use the highest rate that's labeled. For adult grasshoppers, they're hard to kill. They're a big insect and they're tough. So it takes a little bit more product to kill them. Next slide. So next we're going to talk about blister beetles. Now, why are we talking about blister beetles? They're not really a drought insect, but blister beetle populations typically follow grasshopper populations. The reason for that is most of our blister beetle problems that we see, the species, actually have larvae that feed on grasshopper eggs. And so if you have a large grasshopper population, you'll often have a large blister beetle population during the following year. Most of the blister beetle species that we really monitor for in South Dakota are up to 1 inch long, but the colors can vary quite a bit depending on the species. Now, the adults will feed on green plant tissue, but the primary issue is that they're attracted to blossoms. They feed on pollen. As I mentioned, the larvae are actually predatory. Now, why is it a problem that these blister beetles are attracted to pollen? Well, they really like alfalfa. And if the alfalfa starts to flower, we see these things really congregate in the fields. Next slide. Blister beetles get their name because they contain a chemical called cantharidin. This chemical causes blisters when it comes into contact with skin, and not just our skin, but animal skin as well. The chemical is typically released if the beetles are crushed. However, some of them can do reflexive bleeding that depends on the species, where when you just touch them, the chemical can be released in their blood. Contaminated alfalfa, so bales that have blister beetles in them, can be fatal to livestock. Next slide. And so the blister beetle toxicity varies quite a bit by species. The lethal cantharidin concentration is estimated to be 1 milligram per 2.2 pounds for horses. Now, horses are a little bit more sensitive than, for example, cattle. The average blister beetle adult has 1 to 5 milligrams per beetle. So you can imagine it does take a few beetles to cause a major issue for livestock, but if you have a large population present, it's very easy for this to happen. Striped ash gray blister blister beetles have very high concentrations of cantharidin. Striped to average 5 milligrams per adult, ash gray average 1 milligram per adult. So when we see striped grasshoppers out in the field, we get a little bit more worried because it doesn't take as many of them to be a major problem for hay. If we look here at this table, we're looking at species on the left and then estimated number of blister beetles required to cause mortality by weight. So if we look at the striped blister beetle and we're looking at an 825-pound horse, it takes about 120 of them to cause mortality. However, it just varies a little bit. And then also we have to think about the fact that if you have a severe infestation, 120 seems like a lot, especially when you go up to black blister beetles at 1,700 per 825-pound horse. However, you can have a lot of these in a single bale. So the common species, next slide, of blister beetles in South Dakota, next slide, are black blister beetle, ash gray, immaculate, striped, and margined. Next slide. Black blister beetles are about 2/3 of an inch long and their entire body will be black as shown here. Next slide. The ash gray blister beetles are also about 2/3 of an inch long. As their name suggests, they're black and light gray in color. Next slide. The immaculate blister beetles are a little bit bigger. They're going to be 1/2 to 1 inch long. Now their entire body will either be gray or kind of an orange gray in color as shown here. Next slide. And the striped blister beetle or 3 striped blister beetles are pretty easy to identify from everything else. Now remember, these are the more toxic species. They're about 2/3 of an inch long. They're going to be black with orange or yellow stripes on the body. They're going to have an orange head and their head will have 2 triangular markings. So these guys are the ones to really watch for. Next slide. And then the margin blister beetles, again, about 2/3 of an inch long. They can vary a little bit more in color. They will have black and white head and then typically a gray body with black markings. These guys are the ones, along with the striped blister beetles, that can also cause quite a bit of defoliation if you have a large population present. Next slide. So when do we scout for blister beetles? Well, we really need to start prior to each cutting. The reason for that is we need to see what things look like before we actually cut. Now, the second and third and later cuttings are going to be at a much higher risk of infestation. That's because the blister beetles will have emerged and they're going to be looking for flowers. Blister beetle populations are going to be higher in areas, like I mentioned, where grasshoppers were dense the previous year. Next slide. So how do we scout for blister beetles? Well, this one's best done with a sweep net. One of the things we don't want to do is go and bare hand grab blister beetles, because if we grab them with our hands, we will get blisters on our skin. So sweep nets and visual observations are the best. There aren't really established thresholds. So we need to go out, and if you see a lot, especially on the edge of the field, you have to make a decision on what you're going to do. So also make sure you know what species are present and then check from the edge to the center of the field and see what things look like. Next slide. So one of the things to do for management is to try to harvest the alfalfa prior to peak bloom. That's going to reduce your risk of having blister beetles present in the field. Another thing you can do is cut hay, but don't use a conditioner. You don't want to crush the hay. If you crush it, if those blister beetles are present, you're going to essentially force them to stay on the hay. You also don't want to spray fields because this has been shown to actually increase the number of beetles per bale. The reason for that is if you cut the hay and rake it, a lot of times the blister beetles will leave the windrow. If you spray first, though, they're going to die clinging onto the alfalfa, and then they're going to be baled up. So another thing after you cut is make sure you allow the hay to dry fully before raking so that those blister beetles don't want to stay there anymore. Next slide. So some considerations, excuse me, for buying and selling hay is notify the buyer if bales are infested. And kind of a good rule of thumb is just avoid us trying to sell hay if you know you saw a lot of blister beetles, especially to people that are going to be using it for horses. A few years ago, we had a major issue where people thought that there were bales bought from South Dakota. The hay ended up not originating from here, but still caused a lot of issues for a lot of people. Try to use first cutting hay primarily for horses. The later cuttings can be used for other livestock, especially because there's that increased risk. You want to try to avoid using that for horses. And you really want to try to monitor and also sometimes just avoid feeding hay from the field edges. Blister beetle populations will be worse on the edge of the field. And so if you know they're out there, try to either bale that and feed it to a different livestock, or just bale and destroy. That's kind of a individual basis decision making for that, but the edges will be the worst. So that's all I have. You can go to the next slide, Connie. That's all I have for everyone today. I thank you for taking your time to listen, and I apologize for the little bit of technology. I know I missed advancing, having Connie advance a few slides, but I think that the biggest thing I can recommend is even though it's dry, go out and scout, look for the spider mites, keep track of the grasshoppers. As we move in the next few weeks and get into winter wheat planting, assuming that it grows and we get some moisture, one of the things we really have to worry about also for that is having grasshoppers move in early season. And so we'll be watching and monitoring, but some considerations are to go ahead and plant a little bit thicker around the field edges, or maybe even treating along the edges of the field just to slow those grasshoppers down. But that's all I have. Thanks.
Thank you, Adam. There is a question for you. Is there some way to control blister beetles over the winter?
It would kind of depend. So depending on the season, there is maybe the chance we would see some mortality just if we have a really cold winter without snow cover. That would be our best bet for management over the winter, because they're down in the soil. Grasshoppers lay their eggs in the soil, and blister beetles lay their eggs on the grasshopper eggs. So they hatch and start eating them. But you know, it's one of those pests that we don't really want to manage too much, because they are doing us a benefit. They are, even though it might not seem like it, they are reducing the grasshopper populations. Just imagine if we didn't have that reduction, how bad the grasshoppers could be. So really the best thing to do is, you know, for management of these guys, is cut hay before it goes into flower. I know, you know, a lot of people like to wait until we get flowers started before cutting, but that's going to attract them into the field. And so, you know, there's nothing you can do as far as spray, because they are down in the soil. And you know, just something to consider though when you're out scouting. Keep an eye out for them.
Thank you, Adam. I'm going to stop the share. I'm going to let Evan go ahead and load up the poll for Adam's presentation. But if you do have other questions, comments, please drop them in that chat or Q&A for Warren, Sarah, or Adam, and we'll be happy to address them. And again, this poll is the same two questions that you had answered for Warren and Sarah's presentation. All right. Just going to open it up to see if there's any other questions or comments that you have for any of our presenters today. And if any of our presenters have any other comments or something that they'd like to say, I can open it up that way too. Not seeing anything in the chat or Q&A at this moment. Just want to thank you for attending today's Drought Hour, and we will be back with another session of Drought Hour next week. So I just want to thank you for attending the session. If you do if you have missed any of the recordings, you'll be able to find them on our SDSU Extension YouTube channel. And so with that, just thank you and have a great week.